Hi, welcome to our presentation. My name is Win Liu. I'm the CEO of Sharp Vision Software. My team and I are excited to present Avara, a 3D model-based work instruction authoring tool for maintenance, repair, and overhaul. Avara is sponsored by NavAir SBIR Phase 2.5 with the support from NavAir FRC Southwest for aircraft maintenance. Sharp Vision Software is a Texas-based small business serving both government and commercial customers in North America and Western Europe in defense, aviation, healthcare, pharmaceutical, power, and oil and gas industries. Our customers include U.S. Army, Navy, and Air Force, Uniformed Services University, General Electric, Pfizer, ExxonMobil, CAE, BP, Intel, and Spanish Navy.
This project came about thanks to NavAir's Commander Fleet Readiness Center's Advanced Technology and Innovation IPT, or ATI, which is comprised of sustainment experts from the 3 Fleet Readiness Centers. The ATI recognized that the approaches used by the Army to train doctors using 3D models could be leveraged to dramatically improve in-service engineering creation of work instructions and training modules to enhance understanding by the depot-level maintainers at their Fleet Readiness Centers and their satellite facilities. NavAir's migration toward a model-based enterprise, the use of product lifecycle management software, or PLM, and the installation of robust IT infrastructure to support Industry 4.0 helps to set the stage for proliferation of model-based work instructions. The fidelity which can be achieved using model-based content will improve overall effectiveness, productivity, and quality in aircraft maintenance, repair, and overhaul processes. An SBIR Phase 2.5 was awarded to SVS to develop a process for creating 3D visualization models quickly with easy-to-use software tools for in-house development of training and work instructions by Navy engineers and artisans. This SBIR effort provides the required resources to mature the technology to ensure it is acquisition-ready for integration into ComFRC's Fleet Readiness Centers and compatible with PLM tools. The technology development under this Phase 2.5 will ensure a robust and packaged technology capable of delivering visualization models and a software-hardware package for authoring and viewing of the model-based content to support training in MRO. SVS's transition targets include the MRO and fleet support team engineering to production teams, which provide critical support to all NavAir PEOs and PMA products for weapon system sustainment. For anyone who has been to one of the Navy's 3 Fleet Readiness Centers, you'll immediately recognize the importance of these facilities. Many of the same hangars and production facilities that were once preparing World War II aircraft have been transformed to maintain today's frontline aircraft like the F-18 Super Hornet, F-35 Lightning, a variety of helos, engines, and aviation components. For most of their history, the MRO instructions have been provided via old-fashioned 2D blueprints, paper manuals, and local engineering documents. Now that these same facilities are getting a facelift and modernization has begun under the Navy's Industrial Optimization Program, the necessary IT infrastructure is in place to take advantage of new technologies which can streamline operations. The desired objectives for improvement include easy-to-use authoring tool for in-house creation of work instructions and training materials, augmented with embedded digital content such as animations, 3D models, video, job performance aids, audio, photos, text, etc. The ability to convert existing PDF instructions into digital work instructions format for editing and viewing. Hardware solutions to rapidly create 3D content with portable handheld scanning, and software to decimate large 3D CAD files and scan point clouds from existing reverse engineering tools. A work instruction viewer compatible with a variety of IT peripherals such as PCs, mobile devices, and headsets, and the ability to deploy a standalone package or integrate with enterprise product lifecycle management. The system should be capable of developing and displaying interactive 3D content, and lastly, training and support as necessary.
Avara stands for Advanced Virtual and Augmented Reality Instruction System and is broken down into 2 major packages, the software and the hardware packages. With these two packages together, an engineer is able to quickly create work instructions and assign them to artisans to work on said instructions. The hardware package includes two 3D scanners alongside all necessary components to run them, such as a laptop. The first 3D scanner is the Matter and Form 3D scanner. It is a laser-based 3D object scanner. It can scan small objects and save them as a 3D file you can import into a virtual environment or output on a 3D printer. The second scanner is the Peel2 3D, a handheld scanner that doesn't compromise high-quality scans. It can ingest CAD and all 3D files, but can also capture materials along with the models such as clay, metal, and brick. With these two tools, an artisan is able to quickly make a scan, upload the model to Avara, and create an appropriate work instruction depicting the associated part. The software package includes the Avara suite, which includes the web app and the viewer app. There are 5 key features of the Avara software suite and are as follows. Number 1, the 3D model decimator, a useful tool that will take an uploaded model and decimate it to reduce the number of polys the model has. This is important as it lowers the file size of the model, reducing the amount of computing power the hardware needs in order to view the model. Having a 3D model too big causes issues such as lag and potentially application crash. This is due to the hardware limitations of any viewing device such as a tablet or a toughbook. With a 3D model decimation, this reduces the stress on the device and allows for optimal viewing. Number 2, the work instruction author. This allows engineers to quickly create work instructions like REIs and get it into the hands of the artisans. In the work instruction author, the engineer is able to create detailed step-by-step instructions in a timely fashion, allowing them to add attachments like 3D models, videos, audio, images, and PDFs. Number 3, the PDF parser. This allows the generation of work instructions off of the documentation such as LPSs and LESs. The PDF parser takes a PDF documentation and scans all the words and phrases in that documentation and generates a work instruction based off of the documentation. The engineer will then simply look over the generated work instruction and add any supplemental materials to the instruction. Number 4, 3D model annotations. 3D model annotations generated through the work instruction author and viewed on the Avara viewer allows the engineer to pinpoint a specific location on a 3D model, allowing for a more precise description on the task. And number 5, the Avara viewer. The Avara viewer is installed on any tablet device. The viewer is the companion software tool to the Avara web app. Artisans are able to view all assigned work instructions and can go through a step-by-step instruction with ease. The following slide shows the advantages and benefits of the Avara suite, which key features I had talked about in the previous slide. Now, to talk about the current status of Avara, I give it back to Chris.
Avara software has been undergoing beta testing at FRC Southwest with the help of subject matter experts and the MRO engineering staff. During this phase of development, valuable feedback from Navy SMEs resulted in improvements to Avara's functionality and user interface. FRC Southwest team has been able to successfully ingest existing local engineering specifications in PDF form, then enhance the resulting digital instructions in the authoring tool with new digital content. Also, subject matter experts were able to validate the ability to rapidly create new maintenance instructions from scratch and populate with visualization models created from the PL3D and Matter and Form scanning solutions, as well as other scanning equipment at FRC Southwest. Currently, Sharp Vision software is working with the Commander Fleet Readiness Center's ATI to expand user evaluation to other sites to look at different use cases such as technical directives like airframe bulletins, fleet repairs authorized by damage engineering dispositions, non-destructive inspection techniques, and others. Future work for SVS's Avara includes development of augmented reality and virtual reality authoring solutions to further enhance viewing options beyond tablets as peripheral headsets become accredited and widely adopted. There is also opportunity to expand beyond depots for solutions that support squadron maintainers. Of course, Expanding awareness of Avaris within the DoD MRO community is a strategic goal for SVS. In fact, in October 2021, NavAir and the SVS team teamed up to submit the Avaris project as an entrant into the National Center for Manufacturing Sciences CTMA Technology Competition, which spotlights transformative maintenance and sustainment capabilities. SVS takes great pride in the Avaris project being selected as one of 6 finalists from over 80 submissions. This project was presented virtually in December 2021 by the FRC Southwest's subject matter expert Andrew Knapp to a collection of high-level DoD maintenance and sustainment personnel. The briefing used provides an excellent background into the highlights of FRC Southwest use cases, and it can be found on our Navy STP virtual booth. Please be sure to take a look. Additionally, in the past couple months, SVS recently enrolled beta testers from NAVSEA's Port Hueneme Tech Bridge, known as FathomWorks, and additional NavAir sites while we coordinate with the NavAir Sustainment and Digital Office for software accreditation. As you can imagine, the capability that Avaris provides this sustainment community is versatile in its ability to improve work and training well beyond the NavAir Fleet Readiness Centers. SVS is eager to support the entire DoD MRO ecosystem, which includes NAVSEA, shipyards, Marine Corps Logistics Commands, Air Force Logistics and Sustainment Centers, and the Army Arsenals. The time is right. Each of these DoD agencies and their SysComs are undergoing similar industrial optimization and modernization programs, which upgrade the IT infrastructure and allow for migration to model-based work environments. So, what's needed to transition this important capability to the Navy? Several things are underway and necessary to complete before Avaris can be used by the Navy. First, the SBIR program is built upon identifying a transition sponsor, essentially a program with money for follow-on SBIR Phase 3 purchases. Although our primary advocate is the ComFRC Advanced Technology and Innovation Team, they are not a program of record. SVS is working with ComFRC's ATI to coordinate follow-on activity with the Navy Digital Office and Sustainment Group with support from PEO Common Systems. Next, Avara software must undergo cybersecurity testing and complete risk management framework accreditation for use on DON or Department of Defense enterprise networks. A Navy decision is needed whether Avaris will be deployed on RDT&E, NMCI, or in a SecDevOps environment such as Platform One. And although it may be advantageous to integrate with a PLM solution, this could take some time. It should be noted that full Avaris functionality can be utilized now as a standalone system and integrate with the Navy PLM system later. The MRO organizations that would use Avaris can easily retrieve, reuse, modify, and share digital content from existing systems of record. Lastly, we recognize that identification of a proper Navy budget for software licenses is always a head-hurter. It is important to note that this is a sustainment capability and not specific to one weapons system program, but really all programs. Sharp Vision Software recommends that the Navy consider this enterprise software for deployment across their sites and consider a similar approach in associated budgetary decisions as used for their PLM deployment.
Although we developed Avaris for aircraft maintenance for NavAir FRC Southwest, it can be used in any industry for training, maintenance, and repair for any industrial equipment. We have developed a flexible pricing strategy to accommodate customers with various budgetary constraints and requirements. We plan to reach out to potential customers via conferences and trade shows, as well as social media to create awareness of our Avaris product. We are also interested in building partnership for selling Avaris product to DoD, government agencies, and private sectors. To accommodate government and commercial customers in different sizes, budgets, and requirements, we have both subscription model and one-time upfront license with an annual maintenance model. We designed the Avaris software in a way that it can be easily integrated with different product lifecycle management systems. Thank you for attending our presentation. Please feel free to contact us if you are interested in buying our Avaris product or partnering with us in selling Avaris product.